Okay, so this is LDS.C20 sample problem, and in it we're going to be working with this vector b. Basically, this vector b is the set of vectors in the set T. Further, we want to define W, which is the linear combination of T, basically the span of T. And then we want to find another set of vectors R that's a subset of T that has three vectors in it, and so that it produces the same span, so that the span of R and the span of T are basically the same, that they produce the same linear combination span, W. Okay, so to do that, we're first going to have to find B in reduced row echelon form. And when we do that, what we end up with is 1, 0, 0, 0, 1, 0, 1, 1, 0, and negative 2, 1, 0. So two of the vectors we're going to use, because the stats of this RF are that R equals 2, but N equals 4. And that basically means that the dependent variables are 1 and 2. And the free ones would be 3, 4, and 5 if it represented a system. We don't have solutions in here yet, but we're going to assume it's homogeneous. Okay, so we're going to assume another row of all zeros right here for the RF. So we don't need to actually solve it all out. All I want to do is basically capture 3 of these columns that end up producing the same solution as these. So what we need to do first is assume a solution to this. And we're not really going to assume it, we're just going to solve for it. So I'm going to say X is one unique solution to this system, and that X is going to be negative 1, negative 1, 1, 0. So that's a solution to this. If I basically make X4 equal to 0, then it's only these 3 rows that contain the solution. So X3 defines both X1 and 2. So that's what's produced from this, is I get the equation that I can basically form a linear combination from my X's. So I'll get X1 times the first column, B1, so negative B1, and B1's right here. X2, which is also negative 1, times B2. And then X3, which I'll say is 1, and that's times X3. And X3, of course, is negative 2, 1, 2. So plus B3. And all that's going to equal 0. Since I'm assuming X4 is equal to 0, to find my solution to this system, I don't need anything about the X4 column. That is, the information there isn't necessary, not for this. Okay, so let's then rewrite this system as B3 then equals B1 plus B2, or B3 is just a linear combination of B1 and 2. That means B1 and 2 are essential, but B3 is not, because it can be formed for B1 and 2. So that means I need rows B1 and B2. I don't need B3, and I need B4 because, again, in this solution, I assumed it was 0. So that then is going to form my R. So R is going to be the set of vectors. First, B1, negative 3, negative 1, 1. Second, 1, 2, 1. And finally, 4, 7, 4, negative 1. And this satisfies all of the conditions that I was asked for. First, R has 3 vectors, check. R is a subset of T, check, because remember T was the set of vectors that's in B. And then finally, I had to show that these are equivalent, that the solution set for T would be the same as the solution set for R, because both those would be W. And I've shown that up here. Again, we're including any solutions here, and I'm showing you that regardless of the solution, that B3 is a linear combination of B1 and 2. So there it is. It satisfies all 3. This isn't the only set R I could have come up with, but this is certainly one that matches the conditions.